In this video, we're going to look at how you can manually calculate the variance and the standard deviation. We need to be able to do this, especially for the IA, to show that we know how the variance and the standard deviation can be calculated. Before we can do this, we need to know what the variance and the standard deviation is. Well, the variance is a measure of how far each number in a data set is from the mean, and thus from every other number in the set. So it's a way of us telling how spread out a data set is away from the mean. The standard deviation is a statistic that measures the dispersion of a data set relative to its mean and is calculated as the square root of the variance. So let's go through a question. 5 students took a maths test. Their scores are given below. Calculate the variance and the standard deviation. Before we start, this is a measure of spread, and I can hear you asking, well, we've already got a measure of spread, the range. Well, if we look at the range here, it's 88 minus 12, which is 76. So that's quite widely spread out. But instead of getting 46 and 72, if those had also got 88, the range would still be 76, but the data set is nowhere nearly as spread out. So the range isn't really a good way of deciding how spread out a data set is, because it takes the two extremes, the maximum and the minimum. So the first thing we need to do in here is calculate the mean. So the mean is x bar, which is equal to 78 plus 88 plus 12 plus 46 plus 72, all divided by 5, which gives us, when you work it out, as 59.2. The next thing we do is we need to see how far each data point is away from the mean. So we need to do 78 minus 59.2 plus 88 minus 59.2 plus 12 minus 59.2 plus 46 minus 59.2 plus 72 minus 59.2. And we've got to average those out, so we've got to divide by 5. Well, that will give us 18.8 plus 28.8 minus 47.2 minus 13.2 plus 12.8, all divided by 5. If you add up the top, it actually gives us 0. So we get a spread, an average spread of 0. And that's because we found the mean. So what somebody decided to do to get rid of the negative numbers, what we do is we get rid of all this. And instead of taking how far away they are from the mean, we're going to square it. And that is the best way of getting rid of any negative numbers. And then we average it out, which gives us a variance of 18.8 squared plus 28.8 squared plus minus 47.2 squared plus minus 13.2 squared plus 12.8 squared all over 5. That gives me a variance sigma squared of 749.757. Well, I can hear you saying that's a massive number. Well, it is a massive number. But the reason for this is we have gone through and we have squared every piece of data. We just can't go around squaring everyone and expecting a reasonable answer. So that is why we use the standard deviation. So when we use the standard deviation is equal to the variance square rooted, and that will undo all the squares we've got. So in this case, the standard deviation is equal to 27.4 to 3 significant figures. And what does that actually mean? That actually means that if you take those 5 pieces of data, on average, each piece of data is 27.4 away from the mean of 59.2. So that's the average distance each piece of data is away from the mean. And we don't care whether it is above the mean or below the mean. We're only interested in how far away from the mean it is. So to summarize, the variance sigma squared is equal to the sum of each data point subtracted by the mean squared divided by the population size. And to calculate the variance, the first thing you have to do is calculate the mean. Second, subtract the mean from each data value. 3, square these individual results. 4, add these results together and then divide by either n-1 or n. The IB always use the population variance, so you divide by n.